Hey everyone, welcome back. Today we're going to look at the library of functions and we're going to apply that to piecewise functions. So I had asked you all to make sure you knew the 8 common graphs, which I'm assuming you will, and also know their domains and ranges. And we're going to apply that to piecewise functions. So piecewise functions are functions that you graph in pieces. They're defined by different equations on different parts of the domain. So the domain is actually right here. So if I was to graph f of x equals the absolute value of x, the domain when x is greater than or equal to 0 is the function x. And when x is less than 0 for the domain, I'm going to use negative x. And we know that if you graph f of x equals x, that's a straight line going up. And f of x equals negative x would be a straight line going down. And when you put that together, you get a V-shaped graph, which is the absolute value function. So let's look at an example here. F of x is equal to negative 2x plus 1 if x is between negative 3 and 1, not inclusive. F of x equals 2 if x equals 1, and f of x equals x squared if x is greater than 1. So first I'm going to take the first function, f of x equals negative 2x plus 1. And I'm going to plug in these values here. So these are your endpoints. For the first one, when I plug in negative 3 and evaluate the function, you get 7. Because it's a less than or equal to, I know that this is going to be closed. Now when I plug in 1, I'm going to get negative 1. And this time it's open because it's less than. So when I plugged in negative 3, I got 7. So I'm going to go to my graph and I'm going to plot negative 3, 7. And I'm going to use a closed circle, again, because it's x is greater than or equal to negative 3. But now when I plug in 1, I get negative 1. So I'm going to plot 1, negative 1, but I'm going to put an open circle this time at 1, negative 1, because x is less than 1. And then I'm going to connect my line. Okay, and I'm actually going to do that a little bit neater. Okay, now I'm going to connect it. All right, so there's the first portion of the graph. Now I'm going to take f of x equals 2, which is just a constant function, and that's saying if x equals 1. So when x equals 1, I know that I'm going to have just 2. And it equals 2, so that's a solid circle that's going to be closed. And then for my final function, I have f of x equals x squared. It says if x is greater than 1. So I'm going to plug in 1. And when you square 1, you get 1. Since x has to be greater than 1, this is an open interval. So I know that when I plot 1, 1, I'm going to have an open circle. And you can plug in numbers greater than 1, like 2. 2 squared is 4. And because it's greater than 2, it's now going to be a part of the graph, so it's going to be closed. So 2 squared is 4, and the point would be 2, 4. Okay, and if you remember, x squared makes a parabola. Okay, and then if you plugged in 3, you would get 9, and so on. So you would have a parabola that would go up like that. So that's what your graph would look like. Now you can answer some questions about the graph above. So if we have to find f of negative 2, if I go where x is negative 2 and find the y value, so x is negative 2 right here, and if I go up to the line, right there is what my y value is for f of negative 2, which is 5. Okay, I'll let you try B and C. Letter D is locate any intercept. So the easiest intercept to find would be this one, the y-intercept, where y equals 1. And remember, you can express that as 0, 1. To get the x-intercept, remember, the x-intercept is where y equals 0. So I need to figure out here which function I would use. Okay, so the function I'm going to use would be the first one, because that actually is a line segment and it is passing through the x-axis. The other two functions are not, but that one is. Where exactly is it going through the x-axis? Right about there, but we need to figure out the exact value. So I'm going to take f of x equals negative 2x plus 1, or y equals negative 2x plus 1. Remember, to get the x-intercept, you make y equal 0, and then just solve for 1. So if you solve that for x, you end up getting 1/2. And remember, you can write that as 1/2 comma 0 for the intercept. E talks about the range. So remember, range is referring to the y values. So if I look at my graph, the lowest y value is negative 1. But then the arrow means it continues on forever on the parabola. So my range would go from negative 1, not including it, remember it's an open interval, all the way to positive infinity. Next, it asks if the graph is continuous on the domain. So continuous just means, like, is it smooth and are there any breaks? There shouldn't be any breaks if it's continuous. So just remember, for continuous, you want smooth and no breaks in the graph. Okay, so if I look at this, you can see there are clearly breaks in the graph, right? Like there's a break right here, there's a break right there. So there's all these breaks. So it's definitely not continuous. So if it's not continuous, where is it not continuous at? So where is the break at? Right here, right? That's where all my breaks are, right at x equals 1. So it's not continuous. We would also just say that's also known as discontinuous. Where? At x equals 1. So again, if you look at the graphs, you can see where x equals 1, there's these breaks in the graph. Now, if I needed to find the domain, right, it's not asking for it because it's not continuous, but let's say I wanted to find the domain. Remember, domain are the x values. So the lowest x value I have right here would be negative 3. And then the holes in the graph are eventually filled in by those closed circles. So the domain goes on forever from negative 3. So the x can equal negative 3, and then it extends forever to infinity. So it would be negative 3 to infinity. Okay, let's look at the next one. I'll do the first part, and then I'll let you all try to answer the questions underneath related to it. Okay, so we've got f of x equals negative 1/2 x if x is less than 0. F of x equals the square root of x if x is between 0 and not including 4. and f of x equals 2, so there's that constant function again, if x is greater than or equal to 4. Okay, so first we're going to take our first function, f of x equals negative 1/2 x. And that negative doesn't matter. You can put it up top if you want. The whole fraction is still negative as long as the whole thing is negative. It says if x is less than 0. So if I plug in 0 here, I get 0, right? And it's less than, so this is a closed interval. So I know that my point was 0, 0, right? I plugged in 0 and I got 0 for my answer. By the way, that should be opened. It's less than, right? So 0, 0, I'm going to have an open circle right there. And I can plug in any number as long as x is less than 0. So you can plug in -2 if you want. -2 is a good one to plug in because it'll cancel out with the 2 in the denominator of the 1/2. So -1 times -2 is 2. 2 divided by 2 is 1. Okay, and this will be closed now because it is a number that's less than 0. So it's including, it's in that interval. So -2 comma 1 would be my other point, right? And you can also use the slope here, right? My slope is just -1/2. So I'm going to rise 1 and run 2 to the left. So if you go up 1 from that second dot I put there, 2 to the left, you're there. So this is just a array. If you think back to geometry, it's got a beginning but no end. Okay, let me shrink this. Let's look at the next one. We've got f of this x equals the square root of x. And it says if 0 is less than or equal to x, which is less than 4. So I'm going to plug in my endpoints. I'm going to plug in 0 first. And the square root of 0 is just 0. Okay, and since it's x has to be greater than or equal to 0, it's closed. So now I'm going to fill in that circle there at 0, 0. And then I'm going to plug in, let's plug in 4, because we can take the square root of 4 easily. You can plug in 1, you could plug in 2, whatever you want, but try to pick some numbers that are nice. So square root of 4 is 2, and this is going to be opened, because remember it says that x is less than 4. So when I plug in 4, I get 2, so I'm going to go over to the point 4, 2, and I'm going to put an open circle there. Okay, and remember the square root function kind of looks like this. Sorry, it'll stop right here. Usually it has an arrow, but it won't this time because it's just it's stopping at 4. It says x has to be between 0 and 4. Okay, and then I'm going to put my other one here. F of x equals 2. It says if x is greater than or equal to 4. So that means as long as you have 4 for your x value, then the y value is always 2. So, you know, you could have 5, 2, 6, 2, and so on. So 4, 2 is right here. We're going to fill that circle in, and then that graph is a constant function. It's just going to continue to the right. Again, you're going to have a ray there. So that's what your graph would look like. Okay, and then I'll let you all answer the questions below. Okay, I'll let, if you would like, you can pause the video to read the question below, and then we'll do this together. It says a salesman working on commission earns 10% on all sales made up to $5,000. He can then earn 15% commission on the next $10,000 in sales and 20% on all sales above that. Find a piecewise function C for the salesman's commission on the total sales of X dollars. Use the function to determine how much commission he would earn off $20,000 in sales. Okay, so without this piecewise function, you could work this out, but it would become very tedious, right? So what this is saying is, if his sales are $5,000, he'll get a commission of 10% on all sales made up to that. So if you take 10% of 5,000, if I multiply 5,000 times 10%, I get $500. So he would earn, or she would earn, up to at most $500. Once you go past 5,000, it says he can then earn 15% commission on the next $10,000 in sales, right? So the next $10,000, and he can earn 15% commission on that. So what's 15% of 10,000? You got $1,500. Okay, that's how much he earned. And then it says $20,000 on all sales above that. Okay, so right now, if he has made sales of 5,000 plus 10,000, that gives me 15,000. So I need an additional $5,000 to add up to the 20,000. So it says now you can get 20% of that. So 20% of 5,000 is 1,000. And if I add this up, you get $3,000. So you can see kind of how this would be very tedious, right, to have to do this. So we want to create a function that will give us the commission on any sale. And that's where piecewise functions are going to come in. Okay, so our function, we're going to call it c of x. We're going to have three different equations, okay? So the first one says, the first one's going to be that the salesman working on commission earns 10% on all sales made up to 5,000. So maybe he doesn't make $5,000 in sales. He could make $4,050. So x is just going to be the sales, and we're going to have 0.10 times x. So 10% of whatever the sales are. And then we have to put our constraints, so our domain, right? It says on all sales up to 5,000. So it's going to be 0 is less than or equal to x, which is less than or equal to 5,000. So once you hit $5,000 in sales, then you can start making 15% commission on the next $10,000 in sales. So now we've got 15% commission, but we have to remember to take away the $5,000 from the sales. So it's going to be x minus 5,000. Okay, and don't forget, we need to add in this 500. So it's 15% on the next $10,000 in sales. But remember, he earned $500 for making a sale up to $5,000, right? We need to include that. And then what will our domain be? It's going to be for 5,000 less than, so we don't want to include it, x, which is less than or equal to 5,000 plus 10,000, right? Next additional 10,000. That would give us $15,000. And then for the last one, we've got 20%, and this time it's going to be x minus the first 15,000, and then don't forget, plus he made $2,000 for this time x has to be greater than 15,000. Okay, and I'm getting the 2,000 from these two. 500 plus 1,500 is 2,000. Okay, so I have to add that in because he will have made $2,000 in commission. plus the 20% of what he's getting now after he made his next $10,000 in sales. So that's what my piecewise function would look like. Okay, so now we're going to use that to figure out how much commission he would earn off $20,000. So we already figured it out. It's 3,000. Okay, but how would you get it? So here you're just going to plug in C of 3,000. C of 20,000. And 20,000 is greater than 15,000. So I need to plug it into this function here. So I'm going to have 0.20 times 20,000 minus 15,000 plus 2,000. And if you multiply all of that out and subtract and add, you get $3,000. So that's how much commission he would make off of $20,000 in sales. Okay, you can try the problems underneath it. So that ends the video for 3.4. The next one I'm going to cover is transformations. If you have any questions, please reach out.